Hello everyone. Today we are going to move chapter 7 data input and output. We have already seen that the C language is accompanied by a collection of library functions which includes a number of input and output functions. In here we are going to make use of 6 of those functions: getChar, putChar, scanf, printf, gets and puts. These 6 functions permit the transfer of information between the computer and the standard input or output devices such as a keyboard and a monitor. We will see those in detail. First, before we move to the functions, we will see some basic things about those input and output functions. The most versions of C include a collection of header files that provide necessary information in support for the various library functions. As you already know, these files are entered into the program via #include statement at the beginning of the program. So, as a rule, the header file required by the input or output library functions is called stdio.h. It means if you want to use input or output functions in your program, first you must call the library stdio.h. An input or output function can be accessed from anywhere within a program simply by writing the function name which followed by the list of arguments enclosed in parentheses. These arguments represented the data items that are sent to the function. And some input or output functions do not require arguments, though we no need to give arguments but need to give the empty parentheses to indicate that we are not passing any arguments. Now we will move to the first function, getChar. The getChar function we are using for single character input. This returns a single character from a standard input device, typically a keyboard. The function does not require any arguments, though a pair of empty parentheses must follow the word getChar. In general terms, a function reference would be written as character variable equal getChar and empty parentheses, where the character variable refers to some previously declared character variable. You can see an example in the slide. In the first statement declares the C is a character type variable, and the second statement causes a single character to be entered a standard input device and then it is assigned to the C. The getChar function is for get the input from the keyboard. The getChar function can also be used to read multi-character strings. How it is possible? It can do by reading the one character at a time within a multi-pass loop. Then the second function, putChar. The putChar function we are using for single character output for written out of the computer. This function is complementary to the character input function getChar. In here, the character being transmitted will normally be represented as a character type variable. This function expressed with an argument to the function enclosed by parentheses and must follow the word putChar. In general terms, a function reference would be written as putChar inside of the parentheses character variable, where character variable refers to some previously declared character variable. You can see an example in the slide. In the first statement, declare and initialize a C character type variable as string. Then the second statement causes that the single character displayed to a standard output device. PutChar is for display the output. The putChar function can also be used to output multi-character strings. It can done by storing the string within a one-dimensional character type array. Each character can then be written separately within a loop. Now we will see an example which contains both of two functions. In here you can see first I have called the header file for the input and output functions stdio.h hash include stdio.h. Then I have created a main function for the program void main. Then declared a character type variable as char ch. Here ch is the variable name. Then for get the input from the keyboard, I have used the function getChar with empty parentheses, and I have assigned that value to the variable ch in the same line. After that, for displaying, put char inside of the parentheses ch, and remember to put the semicolon at the end of each of the line. When we run this program, it will display a cursor to us to enter the character. So I have entered the A. When we press enter, after entering the A, it will get the character and assign it to the ch variable. After that, for the displaying purpose, put char ch. It will display the ch variable. So it is displaying A. Now I think you have an idea how this works. The third function is scanf function. Input data can be entered into the computer from a standard input device such as keyboard by means of the C library function scanf. This scanf can be used to enter any combination of numerical values, single characters and strings. This function returns the number of data items that have been entered successfully. In general terms, the scanf function is written as scanf inside of the parenthesis control string and the arguments, where control string refers to a string containing certain required formatting information, and arg1, arg2, argn are the arguments that represent the individual input data items. Actually, the arguments represent pointers. That means it indicates the address of the data item within the computer memory. This control string comprises individual groups of characters with one character group for each input data item. This each character group must begin with percentage sign and followed by a conversion character. Conversion character means the characters which indicates the type of the corresponding data item. I will give you the most commonly used conversion characters in the next slide. Within the control string, multiple character groups can be contiguous or they can be separated by whitespace characters. Whitespace characters means blank spaces, tabs or new line characters. If whitespace characters are used to separate multiple character groups in the control string, then all consecutive whitespace characters in the input data will be read, but they will ignore. The use of blank spaces as character group separators is very common in the use. The arguments are written as variables or arrays whose types match the corresponding character groups in the control string. Each variable name other than an array must be preceded by an ampersand. Actually, these arguments are pointers that indicates where the data items are stored in the computer's memory. And however, array names should not be begin with an ampersand. Now we will see some examples for those above points and understand those in next few slides. Before that, here is some conversion characters that most commonly used for data inputs. See, for single character, it means if you want to input single character in your program, you must write %C in the inside of the control string. D is for decimal integer, E and F both for indicating floating point values, I for decimal, hexadecimal, octal integers, O for octal integers, and S for a string followed by a white space character, U for unsigned decimal integers, and X for indicating hexadecimal integers. There is some more conversion characters. These are the most commonly using ones. And here is a sample example for understand the scanf function. First, the inclusion of the input output header file hash include stdio.h. Then the main function void main. Then inside of that I have declared three data items. First one is char item inside of the square brackets 20. This is indicating an array. An array is a collection of data items, all the data items in the same type and accessed using a common name. This is like a list. So in here there can be stored 20 character type data items and the name of the array is item. Then the integer type variable int part number and the float type variable float cost. And then I have written a scanf function. This is the control string and these are the corresponding arguments. This control string contains three character groups. The first one is percentage mark S. S is the conversion character for inserting a string followed by a white space characters. So it want to store the array item which represent a string. When we are giving an input to the S, so it will store in the item. And we are not using ampersand in here because this is a array name. Then the second one is percentage mark D. D is for decimal numbers and corresponding argument is n mark and part number. It means this input value will store in the part number variable. Finally, percentage mark F. F is for indicating the floating point number and it will store in the variable cost. If you enter string decimal point number and the floating point number, for this it will store in the three data items respectively. The actual data items are numeric values, single characters or strings or some combination thereof. They are entered from a standard input device like keyboard. So the data items must correspond to the arguments in the scanf function in numbers, in type and in order. If two or more data items are entered, they must be separated by white space characters. The data items may continue on to two or more lines since the new line character is considered to be a white space character and can therefore separate consecutive data items. Now we will see some examples for those and understand. According to the above sample example that I have given one slide before, think someone entered the input like this: fastener space 12345 space 0.05. So the fastener would be assigned to the variable array named item and the first 8 character of that will fill. Then space, then 12345. So it would be assigned to the part number and 0.05 will assign to the cost. Note that in here the individual data items are entered on one line separated by the blank spaces. The data items could also be entered on separate lines. However, since that the new line characters are also white space characters, therefore the data items could also be entered in the way which shows in the slide. Fastener in the next line 12345 and next line 0.05, or fastener in the next line 12345 space 0.05, or fastener space 12345 in the next line 0.05. All ways are correct and simple. All the all of these ways are assigned in the same way. Then the next important thing is the S-type conversion character applies to a string that is terminated by a whitespace character. Therefore, a string that includes whitespace characters cannot be entered in this manner. It means we can only include a word in here without spaces. If we want to input a sentence or 2-3 words with the spaces in between the words, we cannot do that. If we keep a space in here, then it counted as a next date item, not as the same one. So to avoid this, there is two methods. The first one is the S-type conversion character is replaced by a sequence of characters enclosed in square brackets. Whitespace characters are also must included in this, so that a string can contain whitespace character may read. We will see an example. So in here you can see, first I have declared a variable line. Actually that is an array with 80 characters. Char line inside of the square brackets 80. So it can include 80 characters. Then the scanf function. I have replaced the percentage mark s with the percentage mark and square brackets in here. Inside of the square brackets, first I have keep a space to indicate the whitespace characters. So this line variable can have whitespace characters, and then uppercase letters A to Z, and the argument is line. In here I have given a printf function to just get the output and just to give you an explanation about this scanf function. So see the first example. If we run this program, it will give a cursor to us to give the input. So first I have given the input as New York City. All letters are capital and it has spaces. So when the computer reads this, first it reads N is here, E is here, W is here, white space characters are here, and the other letters also having here. So successfully read the New York City, and it will print the same thing. See the second example. If we give the New York City, N is capital, E, W both are simple. Then when computer reads this, N is in the square brackets, and when simply reads, simply is not in here. So computer cannot recognize it. So it will ignore the rest of the thing. Only N will read. That's why N is only prints. If we give the simple letters also in the inside of the square brackets, it will print the whole thing. But it is some cumbersome. As I have explained using the example, when the program is executed, successive characters will continue to be read as long as each input character matches one of the characters enclosed in the square brackets, and the order of the characters in the square brackets need not to be correspond to the order of the characters being entered. As soon as an input character is encountered that does not match one of the characters within the brackets, the scanf function will stop reading any more characters and will terminate the string, and a null character will then automatically be added to the end of the string. Now the second way to do this is to enter a string that includes white spaces as well as the uppercase and lowercase characters. We can use circumflex followed by a new line character within the brackets. The circumflex causes the subsequent characters within the square brackets to be interpreted in the opposite manner. Thus, when the program is executed, characters will be read as long as a new line character is not encountered. We will see an example to understand this. Here is the same example that I have discussed earlier. but here is the difference is inside of the square brackets I have given circumflex and the new line character. So until it founds the new line character, it will read. For example, like as the earlier, first example is New York City with the capital letters and the white space characters. When I give this to the computer and press enter, the enter key will issue the new line character. So it is signifying that the end of the string. So it will get the whole string and printf function print it. In here the New York City with the simple letters. This is in here only concerning about new line character. So if I given the New York City and then enter, then it will get the whole input and prints output. So it will not concern about capital letters, simple letters, only concerning about new line character. And there are some more important additional features in scanf function. We will discuss some of them. The first one is reading numbers with specifying field width. The consecutive non-white space characters that define a data item collectively define a field. To limit the number of such characters for a data item, an unsigned integer indicating the field width precedes the conversion character. The input data may contain fewer characters than the specified field width. Extra characters will be ignored. Now we will see some examples for this. In the slide you can see if a and b are two integer variables and the statement that is being used to read their values. Scanf percentage mark 3D, it means it can have 3 characters, and again space percentage mark 3D, it also can have 3 characters and the arguments a and b. If the input data is 1 space 4, then the a will assign as 1 and b will assign as 4. If the input data is 1, 2, 3 space 4, 5, 6, then a is equal 1, 2, 3 and b is equal 4, 5, 6 because 3 characters can store. Then the third one is 1, 2, 3, 4, 5, 6, 7. Then a will assign 1, 2, 3 and b will assign 4, 5, 6 and 7 is ignored because a and b both have 3 characters. And the last one, if the input data is 1, 2, 3 space 4 space 5, 6, then a will be 1, 2, 3 and b will be 4 because after 4 there is a space, white space character. So the 5, 6 will assign as another one. So b is equal 4. Then the next feature is assignment suppression. The percentage sign is followed by an asterisk is used to skip over a data item without assigning it to the designated variable or an array. For example, in the slide you can see a scanf function. In the control string there are 3 character groups, percentage mark s, percentage mark d and percentage mark f. S for character type array and it will assign to a, and d for integer type variable and it will assign to I, and f is a float type variable, it will assign to b. But in the second one, percentage mark asterisk d, asterisk is used to skip that character. So if the input is Alice space 12 space 34.5, then A will assign Alice and B will assign 34.5, but that 12 is skipped because we use asterisk in the second character. The next feature is control string without interspersed white spaces. If the control string contains multiple character groups without interspersed white space characters, then some care must be taken with character type conversion. In such cases, a white space character within the input data will be interpreted as a data item. To skip over such white space characters and read the next non-white space character, the conversion group %1s should be used. Now we will see an example. In this example, you can see a scanf function with the control string and the arguments C1, C2 and C3. In the control string, there are 3 C's and that is for single character variables. And there is an important point in here. You can see there is a white space before the %C. It is good idea to precede one conversion character with a blank space in all the scanf functions that you are use, because this causes the scanf function to ignore any extraneous characters that may have been entered earlier. For example, in here there is a blank space that proceeds with %C. This prevents any previously entered extraneous characters from being assigned to the C1. So in here you can see there is no white spaces in between the control string. If we give the input as A space B space C, then white spaces are containing in the input. Then it get it as C1 equal A, C2 equal blank space because this is a blank space, and C3 equal B. If you want to assign A, B, C to the C1, C2 and C3, you have to use the scanf function %C. You have to give the white space before here. Then %1s, %1s. Then it will assign A to C1, B to C2 and C to C3. Or otherwise you can use %C, white space, %C, white space, %C. Then it will assign A, B, C respectively for the C1, C2 and C3. And you should understand there is some variation in the features supported by the scanf function from one version to the other version in the C. There is some difficulties, but above features we have discussed is common and are available for virtually for all versions of the C language. However, there may be some slightly differences in between the implementations. And those are the things that you want to know about scanf function. Then the next function is printf. Output data can be written from the computer onto a standard output device using the library function printf. This function can be used to output any combination of numerical values, single characters and strings. It is similar to the input function scanf, except that its purpose is to display data rather than enter it into the computer. That is, the printf function moves data from the computer's memory to the standard output device, whereas the scanf function enters data from the standard input device and stores it into the computer's memory. In general terms, the printf function can be written as printf inside of the parenthesis control string and the arguments, where control string refers to a string containing certain required formatting information, and arg1, arg2 to argn are arguments that represent the individual output data items. Then the arguments can be written as constants, single variable or array names, or more complex expressions. And function references may also be included in there. The contrast to the scanf function, the arguments in a printf function do not represent memory address, and therefore they are not preceded by ampersands. And also the control string consists of individual group of characters with one character group for each data item. Each character group must begin with a percentage sign. In simply, an individual character group will consist of the percentage sign followed by a conversion character indicating the type of the corresponding data item. And also in here multiple character groups can be contiguous or they can be separated by other characters including white space characters. The use of blank spaces as character group separators is the common one. And in here you can see the several of the more frequently used conversion characters for data output. First, C4 displayed the single character and D4 signed decimal integers, E4 floating point value with exponent, F4 floating point value without an exponent, and I4 signed decimal integers, O4 octal integers without leading zero, and S4 string, U4 unsigned decimal integers, and X4 hexadecimal integers without leading zeros. And note that some of these characters are interpreted differently than with the scanf function. Now we will see an example for use of printf function. As usual, I have included the stdio.h file which includes the input output lib functions, then the main function, and I have declared 3 variables as I used in the last examples, char, item, and inside of the square brackets 20, that 20 characters can include in here, then integer, part number, int part number, and the float type variable cost. And here I have used the scanf function to get the input from the user. And there are 3 printf functions in here. The first printf function for displaying the string, the item, part number, and the cost is. This is directly displaying the standard output device. And there are 2 printf functions in here which includes control strings and the arguments. There is same control string in both, but the second one has white spaces and third one don't have white spaces. In here there are 3 character groups in this control string. First one is percentage mark case that indicates the first argument item and represent a string, and the second one is percentage mark D that indicates the second argument part number and that is a decimal integer value, and the third one is float, percentage mark F for float, and it will indicate that the third argument cost. And now suppose that the item, part number, and cost have been assigned the value as fastener 1 2 3 4 5 and 0.05 with the white spaces. So in the second statement it will get as with the white spaces fastener space 1 2 3 4 space 0.05, and this is the default decimal places. And in here the third one there is no white spaces in the control string, so in the output also there is no white spaces. And I have given the new line characters in the first and second printf statements, that's why it will print by line. And note that in here the arguments in the printf functions there is no ampersand, but in the scanf function except the array names there must be ampersand in the argument types because it is storing the computer's memory. The next point is the F-type conversions and the E-type conversions are both used to output floating point values. You can see an example in the slide. In here, first I have declare and initialize 2 variables, double x 5000.0 and y equals 0.0024. Both are floating point values, double values. and I have given two printf functions. First function for f-type conversions and the second one for e-type conversions. Both printf functions statements have the same arguments x, y, x multiplied by y and x divided by y. And I have given two new line characters in here, so it will have double spaced. In here the output you can see there is a empty line, so it is double spaced. And the first line you can see standard floating point format without exponent, and the second one form of the scientific notation with exponents. For first one is for f type and the second one is for e type. The printf function interprets S-type conversion differently than the scanf function. In the printf function, S-type conversion is used to output a string terminated by the null character. Whitespace characters may be included within the string. Here in the slide you can see the short C program that reads a line of the text and writes back it out. In here you can see the scanf function which I have explained earlier. It gets the input and the printf function displays the output. In here the scanf function control string and printf function control string is different. If we run this program, it will give a cursor to us to give the input. So in here I have given the input as New York City and press the enter. Then it will get into the computer and it will again print as the same. But the control strings used in the scanf function and printf function is different. Not that. And there are some more important additional features in the printf function also. We will discuss some of them. The first one is writing numbers with specifying the field width. A minimum field width can be specified by preceding the conversion character by an unsigned integer. If the number of the characters in the corresponding data item is less than the specified field width, then the data item will be preceded by enough leading blank space to fill the specified field. If the number of characters in the data items exceeds the specified field width, however, then additional space will be allocated to the data item so that the entire data item will be displayed. This is just the opposite of the field width indicator in the scanf function, which specified the maximum field width. For example, you can see the C program in the screen which illustrates the use of the minimum field width. In here, first I have declared and initialized two variables, int I equal 12345 and float x equal 345.678, and there are two printf functions. In here, in the first line, it displays the decimal integer using three different minimum fields: 3 characters, 5 characters and 8 characters. Here is 2 new line characters for double space, you can see in the output. In here, in the first one 3, but the entire integer value is displayed within the field even if the field width is too small. Field width is 3 but this is 5, but this will be displayed. And the second value 5, but it preceded by one white space character, and this generated by the blank space separating the first and second character groups within the control string. and it will also print 1 2 3 4 5. In here also 5 characters, here also 5, then it doesn't matter. In the third value, this is 8, and here it is 4 blank spaces in here. One blank space comes from the blank space separating the last 2 character groups within the control string, and other 3 blank spaces fill the minimum field width which exceeds the number of characters of the output value. The minimum field width is 8, but we have filled by 5. Similar in the F type. Then the next feature is precision specification. It is also possible to specify the maximum number of decimal places for a floating point value or the maximum number of characters for a string. This specification is known as precision. The precision is an unsigned integer that is always preceded by a decimal point. If a minimum field width is specified in addition to the precision, then the precision specification follows the field width specification. Both of these integer specifications precede the conversion characters. A floating point number will be rounded if it must be shortened to conform to a precision specification. Here in the slide you can see an example for that. In here first I have declared and initialized a variable float x equal 123.456, and I have given a printf function with a control string and the arguments. The first one is percentage mark 7f, percentage mark 7.3f, and percentage mark 7.1f. And in here first one it is not mentioning about decimal points, so it's gave the default number of decimal point. And the second one, there are 3 decimal places, so in here 3 decimal places will display, and the last one only 1 decimal place, so this will rounded off 6 to 5 and the 5 to 4, so 123.5. This will rounded off because there is only 1 decimal place in here. And also the leading blanks that are added to the field the specified minimum field width, 7 characters in there. A minimum field width specification need not necessarily accompany the precision specification. It is possible to specify the precision without the minimum field width, though the precision must still be preceded by a decimal point. Here is the last example you can see in this slide, but in here the second and third character groups there is no minimum field width specification. On the precision specification is here. So in the output is same as the last example, but in here you can see in the third number does not have multiple leading blanks, since there is no minimum field with the that must satisfied, so it's only having the normal blank and giving precision specification. In all other aspects, however, output is the same. Minimum field width and precision specification can be applied to character data as well as the numerical data. It is applied same manner in the both. So the precision specification will determine the maximum number of characters that can be displayed. If the precision specification is less than the total number of characters in the string, the excess rightmost character will not be displayed. This will occur even if the minimum field width is larger than the entire string, resulting in the addition of the leading blanks to the truncated string. Then you can see an example in the slide. In here, in the printf function, first the minimum field width is 10, then second one is 15, third one is 15, and the precision specification is 5, and the last one only the precision specification it is 5. If we give the input as hexadecimal, this is string, then the first string you can see in here it is shown entirely, even though this contains 11 characters but the field width specification is 10 characters, this will display all. Thus the first string overrides the minimum field width specification, and the second one padded with 4 leading blanks to fill the out of the 15 characters in here, and hence the second string is right justified within the its field. In the third one, in here consists of five non-blank characters because of the 5 precision and 15 minimum field width. So however 10 leading blanks are added into here to fill out the minimum field width specification with 15 characters. So in the last string also contains 5 non-blank characters. Leading blanks are not added. However, because there is no minimum field width specification, there is no minimum field width specification in here, so there is a normal blank in here. The next point is using flags. In addition to the field width, the precision and the conversion character, each character group within the control string can include a flag which affect the appearance of the output. The flag must be placed immediately after the percentage sign. In here you can see some commonly using flags. The first one is minus mark, that is for the data item is less justified within the field. Blank spaces required to fill the minimum field width will be added after the data item rather than before the data item. And the next one is plus sign, that is for a sign plus or minus will precede which signed numerical data item. Without this, only negative data items are preceded by a sign. Then 0, it causes the leading zeros to appear instead of leading blanks, applies only to the data items that are right justified within the field whose minimum size is larger than the data item. And the next one is blank space. A blank space will precede each positive sign numerical data item. This flag is overridden by the plus flag if both are present. And the next one is hash or X type conversion. We are using that. It causes the octal and hexadecimal data items to be preceded by 0 and 0x respectively. And then again hash for E, F and G type conversions. It causes a decimal point to be present in all floating point numbers even if the data item is whole number. Also prevents the truncation of trailing zeros in G type conversion. You will easily understand these things when you are doing practicals. In here you can see an example with the using of the flag with the integer and floating point numbers. In here first I have declared 3 variables and initialize them. Int I equal 123, float x equal 12.0 and y equal minus 3.3. And in here this is the output that we can get it from this C code. And you can see in the first line there is no flags. It shows how the integers and the floating point numbers appear without any flags. Each number is right justified within the respective field. And in the second line it shows the same numbers but using the same conversion with the minus flag included within the character group. Note that the numbers now left justified within their respective field. In the third one, it shows the effect of using the plus sign flag. The numbers are right justified as in the first line, but each number, positive or negative, is preceded by an appropriate sign. In here, both are plus. And next, in the fourth one, it shows the effect of the combining minus and the plus sign flag. The numbers are now left justified and preceded by an appropriate sign again. And in finally, last, it shows the two floating point numbers, each displayed first without and second with the hash flag. So I think you have get an idea how to use using flags. I will explain these things in the practical classes more than this. The last important point in here is unrecognized characters within the control string will be displayed just as they appear. This feature allows us to include labels and messages with the output data items if we wish. For example, you can see in the slide I have declared and initialized four data type variables, four floating point data type variables, and there are two printf functions. In first one, $sign percentage mark, 4 is the minimum field width and 2 is the present specification in here. So it will display the argument is A, so 2.2, it will display $sign 2.2. In here, the second one, there is two percentage signs in here. The first one is indicate the start of a character group and the second one is for interpreted the label. So it will display the B is minus 6.2. So it will display minus 6.2 and the percentage sign. Like as the second one, x1 and x2 will display in here. Those are the main things you want to know about printf function. And same as the scanf function, remember that there is some variation in the features supported by the printf function in different versions of C. These above discussed features are very common, though there may be differences maybe in the implementation. Then the last two functions are gets and puts. Gets and puts functions facilitate the transfer of strings between the computer and the standard input and output devices. Each of these functions accepts a single argument. The argument must be a data item that represents a string, that means a character array. The string may include byte-space characters. In the case of gets, the string will be entered from the keyboard and will terminate with the new line character. That means the string will end when the user presses the enter key. The gets and puts functions offer simple alternatives to the use of the scanf and printf for reading and displaying strings. For example, in here you can see this C program reads a line of text into the computer and then writes it back out in the original form. This program utilizes the gets and puts and rather than the scanf and printf to transfer the line of text into the computer and out of the computer. Note that the syntax is very simple. In here gets inside of the parenthesis the argument line and puts puts and inside of the parenthesis line. From the gets it will get the input as hello and give the output as hello in the same way. On the other hand, the scanf and printf functions in the early examples can be expanded to include the additional data items, but in here we can't do that. So those are the main things you want to know about gets and puts functions. Okay, now you have an idea about the 6 input and output functions that we are using in C codings. The first two are getChar and putChar that allows the single characters to be transferred into and out of the computer. Then the next two is scanf and printf. They are somewhat complicated, but they permit the transfer of single characters, numerical values and strings. And the last two is gets and puts. They facilitate the input and output strings. Now just get the brief idea. In practical classes you will get the idea clearly about those. We have to do this stuff with the practicals, otherwise it is somewhat hard to understand. Anyway, follow the theory lectures for now. We will do practicals later. And you can go through the reference books and find more details about these things. And I have uploaded the PDF version of these slides. Find that. If you have any doubt, you can contact me through the email I have given as the usual in the first slide. Thank you.